In order to interpret a confidence interval, we compare a specific value to the interval. And whether that specific value is contained in the interval or not helps us draw our conclusions. In example 5, we have a scenario that we already established. The conditions were met to estimate a mean. Now we're given some additional information. We're told the 99% confidence interval estimate for the population mean calculated from the data collected was 49 to 58. Can we conclude from these results that the average percentage of people in other countries who feel similar is less than 88%? We have two different pieces of information we are concerned about here: the confidence interval itself and this value of 88%. We want to compare 88% to that interval and use that to draw our conclusion. In this case, all values in that interval from 49 to 58 are less than 88%. That tells us that yes, we can conclude this because all values in the interval are less than 88%. So it's likely that the true population mean is less than 88%. In example 6, we have another case where we already verified that the conditions are met to estimate means, and then we're told that the 95% confidence interval estimate for the population mean calculated from the data was 54 to 62. Can we conclude from these results that the average number of monthly alcohol-related car crashes in this city is greater than 56? So our confidence interval ranges from 54 to 62, and our value of 56 is contained in this case inside that interval. So in this case, no, we can't draw that conclusion because the interval contains values equal to or smaller than 56. Every value in our confidence interval is a likely value for the true population mean if what we want to say is that the average number of monthly alcohol-related car crashes is greater than 56. Well, our interval says it's possible that the population mean is equal to 55 because that's a value contained inside our interval. In example 7, we have a case where we said the conditions were not met to estimate a population mean. So even though a population mean was calculated here, which is mathematically possible, we have to know that since the conditions are met, we cannot draw any conclusions based off this information. So it is mathematically possible to still construct that confidence interval estimate, but even though it can be created, it essentially has no meaning because the conditions for its creation were not met. In example 8, we have another scenario where we determine that the conditions were met to construct this confidence interval estimate. And then we're told the 90% confidence interval estimate for the population mean was negative 4.4764 to 4.84. Can we conclude from these results that this treatment is effective in helping people gain weight? In this case, what we would want to see is values strictly greater than 0, because the data is on the change in their weight. If we want people gaining weight, then that change in weight should be something positive. So in this case, we would say no, we can't make this conclusion because the interval contains values equal to or less than 0. Meaning it's possible that the true population mean is -2, meaning on average people who go through this therapy are actually losing weight, which would have the opposite effect that we would intend. In example 9, we have a case that sounds similar to one we've considered for, but we have some different values. We're looking at the number of emergency room visits for non-occupational firework-related injuries. We can start off by seeing that our sample size is small. We only had 12 different cities that were looked at. So we have to look at the skewness, which in this case is between -1 and 1. So the data is approximately symmetric, meaning it's likely that it comes from a normally distributed population, so the conditions are met to estimate a mean. Since the conditions are met, then the confidence interval that was constructed is valid, and we can use that to draw conclusions. Can we conclude from these results that the average number of firework-related injuries in the first half of July each year is greater than 114? If we look at 114 and compare that to the values in our confidence interval estimate, all values in that interval are larger than 14, so we would say yes, we can make this conclusion because all values in the interval are larger than 114.